Can you make money on the moon from the moon, Simon? I suppose from the moon. But is there silver and uranium on the moon? I suppose there could be everything up there. But is it up there in commercial quantities that we can extract it? And is there a spot for investors to make any money on that? Is it the same as asteroid mining? Is it going to be new resource Star Wars? There's lots to discuss here today, Simon. And you and I met at the Deutsche Goldmesse in Germany a couple of months ago, and you told me that you're looking for something on the moon, natural resource on the moon. And I have low key been making fun of the idea for a few months on the channel now. Maybe because I don't understand it, maybe because I don't see the value prop or whatever, which I imagine is pissing you off a little bit. So talk to me. Start high level. Resources on the moon. How? What? Why? When? What's going on?
To me, it came about because I'd started a company called Space Ventures Investors, and I was doing surveys for prospective investors. Half of them wanted to invest in something related to asteroid mining space resources. So this was back in 2019. I spoke to my business partner about it, and we just thought, okay, what is it? What's the reality about it? And after a lot of research, uh, I kind of whittled it down to what's possible in my life. If you think of space resources, what's possible in my lifetime?
Hmm.
And it was the moon. It's 3 days away at the best. Um, and there are resources there, and there's been missions, orbiting missions, looking down with different kind of sensors, looking for resources and mapping it for decades now. And in the last few years, there's been more missions to the moon, which are kind of more directed at with the resources focus. So there's renewed interest in it, uh, and there's a whole community bubbling up, from an engineering perspective, building tools and building the supply chain to make actual mining on the moon possible.
Hmm. And you're part of that supply chain. Like, what are you trying to do? You're trying to make the picks and shovels for the guys who are going to be mining the moon, or do you want to go and do it?
Great question. So often the funding for the technology to process resources on the moon or process the regolith that comes from universities, as an example. So their funding is quite particular. Like, maybe someone wants to develop a way to use molten regolith electrolysis to extract, magnesium or aluminum or titanium out of lunar regolith. So for them, their goal is to solve one part of the supply chain problem. My goal as the company we formed, Lunar Resources Registry, was to look at it from a planning perspective, look down and work out, well, also from a mining perspective, how do you start? Where do you start? And so we look at it from a locations perspective of where are the locations on the moon that have a high resources, not high value, to be honest, based on remote sensing data. And so then we start looking at as a mining company, where are the regions where what is the terrain where you'd actually have to eventually operate. So that was my kind of self-described role in this. But I know other startups, entrepreneurs, engineers who go into, someone's making a rover or someone's, trying to work on a drill or something like that.
I have about 417 questions off of that in my mind. So I hope we're gonna talk about everything from financing to costs to some of the technicalities as well, because I don't even know. Well, I don't think there's. I hope there's no water up there, stuff like that. We'll talk about lunar dust and everything. But wait, so how do you? Yeah, you said remote sensing, but how do you even know there's anything out there? I mean, you haven't been. Arguably, nobody ever has, but maybe that's a triggering topic. But so yeah, how do you know what's the process of identifying resources on the moon, and how far can we trust them?
Yeah. So the US have sent a lot of orbiters up there. Koreans, Chinese are doing it. The Chinese released a new geological map of the moon. So the remote sensing is sensors that look down and I've looked at the data for, as an example, where iron is or titanium dioxide or um, I'll use those two as an example. So the remote sensing, it might be widely inaccurate. Like you're looking at a map and it's 1 pixel equals 1 kilometer or something. On Earth, Earth observation data, 1 pixel might equal 50 centimeters. So you're looking at kind of bulk data, but as more missions go to the moon, they're carrying more precision equipment to really ascertain where on the moon are resources in um, groupings, so to say, that could warrant a potential exploration mission.
But it's kind of geophysics. I mean, it's not nobody's drilling up there, right? It's just kind of surface gasping the lithology of the moon, if you will.
Yeah, this is a really good point. So the lunar sample return missions, which were from the Apollo program, the Russians did a few, and the Chinese did one, their Chang'e 6 mission, I think, last month, and that I think returned like 1.9 kilograms. Whoa. But the question is where were they taking this sample from? And they were taking this sample from a mera, which was used to be a sea, and that area, I assume they were trying to get to find out in that old lava sea, which hopefully had material from the subsurface, which is more metals. So my knowledge of it is that they're looking to find out what metals are in there in that particular location. So as a lunar resources registry, we map where missions go, and then we look at our resources maps and try and work out, well, why are they going there, or why is that company going over there? Some of it is, some of these missions are, you could almost say, you could think that they're like flag waving missions, or um, very scientific focused. We look at it from a point of view of, from a resources point of view, is are they going to areas that might have resources? And if they're doing, some kind of science there, then what's the science about? Is it about finding resources?
So you're basically basing this on the assumption, or your starting point is the giant impact hypothesis that 4.5 billion years ago something hit Earth, debris. Over time, it kind of condensed into it being the moon. That's what you're basing the geological thesis as if it were on.
Yeah, so that thesis is they Earth Moon bang came apart. The the makeup of the Earth is pretty much the same as the moon. Uh, there is more kind of metals below the surface. The fun part about the difference between the moon and the Earth has had temperature rising, cooling from a geological point of view over billions of years. The moon hasn't had that. The moon formed pretty much cooled down. But what the moon does have is sorry, it doesn't have an atmosphere. So on Earth, anything that comes in and meteorites, they get pretty much get burnt up. On the moon, it doesn't happen that way. So the moon's had billions of years of what's called weathering, where any object that came down, it pretty much makes a massive crater and everything gets pulverized. So I classify the resource potential of the moon in two ways. One is there's the subsurface material, um, which in my lifetime I don't think we're going to drill there. It's just too expensive, too far out. Maybe. But on the surface, you've got weathering, and some of the meteorites are very heavy in nickel, or iron. And so the remnants of those areas is where there could be resources found amongst, the regolith, which is all, finely pulverized.
Mm. I again, towards the second part of the conversation, I hope we can get into the specifics and talk about how do you deal with there not being an atmosphere to begin with. But basically, what it comes down to is that this is similar to exploration on Earth, where until you go and drill it, you don't quite know. But only on Earth we have other stuff. I mean, we have trenching, there's geochem, there's geophysics. Like you can have 5 steps to come up with drill targets, and on the moon you're only relying on this distance
Remote.
sensing, basically remote sensing. Um, so that makes your drill targets what higher risk.
Yeah. So on Earth, geologists can go out and, with a hammer and a pick and a magnifying glass. Moon, you can't do that. So target selection is at the moment based on remote sensing. Part of what we do is going to the next level and trying to work with technology to partners to make, what we call hundreds of lunar landers, basically mini drill rigs that can solve this problem of missions to the moon are expensive. Let's just call it 100 million a pop. One of our long-term goals is to get that down to, I call it, a million easy number, so that we can do what mining exploration companies do. They go out, they drill 100 holes, they get the data back and say, all right, well, this is a good piece or not a good piece or
Yeah.
whatever. That hasn't happened on the moon because we're completely reliant on remote sensing in very few sample return mission locations. There needs to be more exploration done. So where we're at in this nascent industry is a lot of emerging companies, emerging investors are trying to find out, well, how do we up the exploration effort and where to go to actually ascertain what is really there.
Financing is going to be a big question that I have out there. You're basically trying to get with the costs down 99%. So I also want to, I mean, from 100 to 1 million. And I also want to know how you're doing that. But let's maybe back it up a little bit and talk about the why. Like, well, why do we even need to? Is this a science project? Like, do we have plenty of resources on Earth, right? Which is, and it's really not easy to get. So why even go and make it way harder? Like, what's the reasoning?
The reason I kind of split the reasoning into different areas, and I'm going to start off with the desire for exploration. I really think it would be a shame if in our lifetimes we didn't, as collectively as humanity, that educated humanity armed with the best engineering and analysis, we didn't even try to approach the moon as a potential for resources to integrate with what we do on Earth. So that's just kind of almost the emotive rationale. Another rationale is exploration, science, missions going to the moon. They want to go to the moon and use resources on the moon. It's called in situ resources utilization. So why haul 3 tons of metal to build a moon base if you can get it on the moon, extract it from the regolith, and build it from materials on the moon? So that's number one. Number two is utilizing resources from the moon into the cislunar economy. So cislunar Earth Moon. And now you get into, if you can extract titanium and refine it, you need a lot of energy to do that, then you can build that into your infrastructure. Another thing that is of value of the moon is the big question of water, extracting water, which is pretty much molecules trapped in concrete. So again, you need a lot of energy to do that. And then from that, you can have oxygen, which supports life, and also use it in propulsion. And then you're able to use the moon as like a fuel stop to then go explore other planets.
When I ask why, I appreciate that question. It's kind of it's almost a philosophical answer when I start thinking about it. Like we should be doing it. I was thinking more like why from the capitalist perspective. Like if I can make money as an investor here on Earth, why would I bother? And is there really a way? I mean, you're not publicly listed. I mean, there's virtually no way for you to make me money. I suppose there's one company I can think of that you can get exposure to, but is there? Why would I care as a retail investor? Can I really make money or do anything with this information?
Yeah, no, you can. There's this quote. A couple of people have said it. The first trillionaires were made in space. From space resources. So I look at it as there's enough unknowns about particularly the moon. There's been a lack of exploration, and exploration will at some point find what's really of value. So I kind of look at I kind of use platinum group metals as as a sign or as a goal. It might be something else that's on the moon that is of value. So at the moment, the focus is fund more exploration to find out what is of real value. Because everyone knows, oh, well, even if you find something of value, but by the time you get it back to Earth, the cost is, astronomical. Um, that's a good point. Uh, but to me, the moon hasn't been fully explored enough to fully understand what is there and what is of value. Another point is that our markets are full of things that, for example, in the luxury goods market, things that have immense value because it's a brand or it's this kind of object or whatever. My simple theory is the first customers for lunar resources might be extracting aluminium from regolith and bringing it back and turning it into a watch face for an expensive watch. That could be the first customer where you extract something from the moon, you bring it back in small quantities, and you integrate it in the luxury goods market. That could be the first thing. The a real goal would be having a refining operation on the surface of the moon to get some metals out that could be used in the construction of bases. Yeah.
That would be a big operation too, so I can see the first part. But to your point about the luxury market, there was this article is kind of it's kind of a craze these last couple of days where Italian investigators found that Dior, the brand, has paid like it costed him like
57 or
57
something.
bucks or something like that to make
Yeah.
a bag, and they were selling it for 3 grand or 2,800 be specific. I think the number was somewhere around that number. There's value, and I call that value. I mean, as an investor in Dior, I mean, I like that margin. With you say find something of value, but the thing really is only of value if it has commercial viability. Right now, it has no value. Even if you find, a billion pound of gold bars on the moon, we don't know how to get them back. Um, so how is that of value? What do you mean when you say of value?
Okay, so luxury goods, as an example, before the imagine a a top brand watch has parts made from the moon that just fits into the usual luxury goods category
We
of
already have that,
exclusivity.
no?
Say again?
Do we not have that already? I think I read something, or was that could have been
Not
fake?
not not that I know. No. But I've used that as an example of how you begin to motivate market participants to invest in lunar exploration for resources. My theory is you find things which you can get into easy enough. So easy example, can you use lunar resources, return them to Earth, integrate them in the construction of expensive goods, right? That's one thing. Uh, I think the end goal is similar to what the uh, the old world empires did with the opening up of the new world. So Spain, as an example, it was able to um, discover the new world and then ship over massive amounts of silver and gold to fund their empire. And you can still see this in Europe, where a lot of the great architecture, a lot of the great buildings, it it came because they were able to go somewhere and get resources and bring it back, which had value. So that is the big goal: is can a country, an economy, benefit massively from discovering something to do with space resources and leverage it enough to make a have a major windfall. That's the end goal.
That's not that's the end goal. That's a fair point. That's kind of how I understand as well. That's not now. So when we go back to the point of how do I make money on it? Like I don't want to make money in 50 years. I want to make it now. How many years are we away from any sort of commercial viability in your opinion? And I understand it's going to be a guess, but what would you guess it is?
For as an example, lunar mining or being on the moon as a
Just making
business.
money on this for investors. Like I put money into something today. When can I expect an ROI?
Yeah, I would estimate it could be 10 years, and it would be based on something like the ability for an exploration effort to go to locations on the surface of the moon, verify, this is the key thing, verify that there are actually resources there. And similar to a junior mining company goes out, drills 100 holes and says, this piece of moose pasture actually has, 3 grams of gold per ton or something. Um, that's how I think it plays out in the next 5 to 10 years is exploration efforts that clear the mystery on what's on the surface and say, look, here is actually an area where it has value. There might be easy to access iron that can be used for a building of a structure like a space base or a moon base. Now, however, I always say if you're supplying materials to a moon base, basically you're just serving a government contract, which isn't really a boom. So I think the innovation required to explore the moon is worth investing in because the payoff can be completely massive. So what happens if someone finds a massive deposit of iron that's also, has a high proportion of something like platinum on the moon, somehow, 2 meteorites crash in one area or exposed as part of the subsurface and the terrain is easy to access. It's these things which I think are going to come up with more exploration, and it's going to turn from a concept of mining the moon, will it work, will it not work? It'll be more like, well, there's a handful of locations where it's now possible to deploy a supply chain and actually start extracting materials.
Well, so here's how I look at why do exploration companies who find something and have a deposit, why does that have value? It's not as if we're going to be mining it. Like there's a lot of these exploration companies that are too small to mine what they have, but the thing they have still has value. So they have a $50 million market cap or $100 million market cap, but they started at 5. So I have a 20x, for example. Why? Is because there's the potential for a major to come in and buy them. Or there's the potential, although far reached, for some of them to develop it and start making money off of that and deploy profits among shareholders. That value, when you find something on the moon, where is it? Like there's no majors on the moon. Who's going to buy the depositor? Like who's going to develop it? And how many years is that away from us?
That I don't know, because in terms of the technology curve, where we're at is using remote sensing data, looking down, finding locations, and then working with technology partners as to what technology can be used to go there to actually confirm a resource. Okay. So using remote sensing data is great, but it's, as you know, from the mining point of view, you've got to go somewhere and drill. Yeah. Correct. So that I think is the game changer, is when missions to the moon are actually sampling regolith and ascertaining, what is the real value, or what resources are there? Where are the locations that will be mines on the moon of the future?
So when you say 10 years, when you give me that time frame, what you're saying is we can have drill targets in 10 years. You're not saying we're mining the moon in 10 years.
I know. We from our work, we have drill targets. So if for some reason someone gave me, I don't know, 100 million, I would say, well, how could we divide that up into 10 missions and go to 10 locations and start sampling the regolith? That would be the goal.
But it'd be surface sampling. I mean, it'd be the equivalent of what juniors do with surface sampling. So, and surface sampling is not, it's the preparation to drilling, right? I mean, it's part of the target generation. Again, as we said, they walk the bush, they do surface sampling, chip sampling, trenching, geochem, geophysics, and that entire process. And so you what are we 10 years away from in that process? We're 10 years away from drilling or from mining the moon?
We could be 5 years away from having commercial missions to the moon with landers, rovers, equipped with laser spectroscopy to um, zap the surface of the moon to try and work out areas that have a high enough resources value that would mean that you could go to market, raise capital to then launch a drill rig there to start drilling and finding out what's really below. So the there's quite a few people developing rovers and other exploration equipment. The reason why they're developing rovers is A, exploration, and B, once you equip it with a payload, which is a resource exploration payload, then it starts making sense as it's no longer just a rover for the sake of exploration, but it actually has to have a payoff. So the engineers, inventors of equipment to do all this, they very much they have it in the top of their mind that there has to be a customer, and the customer has to be in this case, a resources customer. Yeah, so it's a nascent industry, but it's also an industry based on who's going to pay for this and why they're going to pay for it and where's the payoff.
I can see the argument for picks and shovels makers who, if this was 1840 in California, you make a lot of money. This is 70-40 and you try and sell picks and shovels in California, though, there's nobody there to buy them. And so you have to, it's going to be the right, so you have to develop the right technology, but at the right time as well, before running out of capital, right? Because these are non-revenue generating businesses for the most of it. But I think, and that might be a rabbit hole, so I don't necessarily want to go down that rabbit hole because I think that sets up the stage nicely to talk maybe more about the specifics. Because so far I've been saying we multiple times. Well, what do I even mean by we? Like who even owns the moon? You said the Chinese are going there, the everybody's going up there, but where do you go for permitting? Permitting's a big thing in natural resource exploration here on Earth. How does that work on the moon?
Well, welcome to the rabbit hole. So, Outer Space Treaty prohibits owning anything in space. So, basically, you can't own something. Therefore, from a mining point of view, where do you stand? Our understanding is that the US has passed a space mining law. Luxembourg has also done the same thing, where they will recognize your ability to extract something and trade it commercially. There's other things where if you land something on the moon, you're allowed some what you call a safety zone or a don't destroy my craft or don't land next to my craft because you might blow up a cloud of abrasive regolith that shreds mine. So there's ways to meander through and say, hey, if there's a high resources area, you've actually got to put something down there and say this is actually operational or it's an artifact. Stay away or don't land on top of me, for example. So there's ways to go through the legal challenge that there is no ownership of space, but because it's a new frontier, it's also exciting. Like if there's a high value area, who's going to get there first? Are they going to get there? Are they going to be right on target? And a lot of the work we do, as I said before, is we look at the missions that are going to the moon, where they're going, if they get there, do they get exactly where they want to go? And if they get where exactly where they want to go, what's science are they doing there? The puzzle starts to shake, or the pieces of the puzzle start to come together, and you start to get a picture that this is a resources race, but life goes on back on Earth, so it's a slow moving process.
If you don't own it, what does that even mean? I mean, you go there, you don't have a concession because who's going to give you the concession if nobody owns it?
Well, this is the fun part of it is when you look into the laws and the the laws that try and say what to do with space but pretty much came out of the Cold War. Um, and so you could imagine, the kind of frigidness of laws. Now we have, new technology. Example that the cost of launch is coming down, which means it's getting cheaper to send objects into space. It's going to get cheaper to send landers to the moon. Um, let's say the law holds itself and it's respected that you can't own anything. That's fine. It's just the ability to actually get there is a statement of its own. But in our case, we're thinking of resources as the US and Luxembourg have gone ahead with their own version of laws. They will accept your right to sell a resource as a commercial thing. So the resource, once extracted, it's no longer a zone or a piece of land or whatever. You've extracted the resource. It's now it can be made into a commercial object. That's the difference.
Yeah, it's confusing.
Yeah, no, it is. We struggled for years to try and work out what exactly does the law say, what are the new laws saying, what are the new laws about. I think the US and Luxembourg are being very progressive in making these laws and understanding that for a flourishing space resources economy, companies need certainty that if they extract something from a crater, they don't own the crater, you can't own the crater, but if you refine, extract, and you've got let's call it oxygen or nickel or whatever, that can be traded. That can be a commercial product.
I'm trying to look into the Outer Space Treaty, which is confusing as well because it's from the late 60s too. I mean, is there no modern legal framework around this?
Yeah, there's lots of groups. Let's just call them NGOs, and
It's getting even more
who are trying to
confusing.
reframe it, and try and work through it. And you kind of get bogged down in this academic world of who owns the moon and all that. As an individual, time is precious. We look at it and say, hey, where are the resources? What parties out there want to be part of this resources exploration? Um, just by getting to a location is a statement in itself.
Yeah, it's again, I'm gonna go back to my comment of it being confusing. Was there so if I want to I cannot stake, like if I want to stake my own ground on the moon for exploration, I cannot do that.
No,
I'll
you
just
can't.
basically have to fly out there. Who's gonna have to give me permission to fly out there?
Well, then that would you'd have to go back to the authorities that manage the launching of satellites as a base. So
Okay.
there's so many levels of bureaucracy and oversight. Fair enough. Before launching anything into space, as your local government, your local space agency will want to know where you're launching it from. Are you going to go through any flight path? What orbit is your satellite going to be in? And there's even new laws coming out. Sorry, not new laws, but more, let's say, motivational um, efforts to say, for example, if you have a satellite, how are you going to deorbit it so that it doesn't, so that when it runs out of propulsion, it's just not, dead in its orbit and a potential space debris accident. So there's already so many levels of governance in place to in order for anything to blast off from Earth, getting to the moon, um, it's not like the Wild West where anyone can go and do anything when they want because there's a lot of collaborative efforts. For example, how are you going to how are you going to maintain contact with your lander without relying on an international system of communications infrastructure that goes out that far?
Yeah. And yeah, again, it's just I think this could indeed be a rabbit hole, as you said at the beginning. Um, but it's also, I mean, it is an important part. Permitting is a huge thing here on Earth that's getting more challenging. At least you're not dealing with any local communities up there, hopefully.
No, there is no um challenges like that. So it is kind of like an open frontier. It's just that it's expensive. At this stage, it's more of trying to work out where do you exactly go and what's the business model tied to that.
Yeah.
So, as an example, um, we try and work out where is a location that has potentially enough resources that would warrant a exploration mission to go and sample regolith, and if that comes up positive, then could you raise money to send another lander there to start drilling and refining?
Hmm.
Um, that's
But
how we see it. Is it's still early stages, trying to work out locations, value, business model, investors, timelines, and markets.
so everything.
Yeah, you've got to work out everything in order to understand it. But we're confident from what we see in the space resources community. There's enough teams out there who are developing their own part of the supply chain. So one team might be working on how to refine regolith. Another team might be working on how to do rovers or navigation on the moon. At the moment, there's um, no GPS or Galileo system on the moon. So
Yeah.
um, a lot of supply chain infrastructure has to come together in order to have sufficiently functional operations. Uh, but the good news is a lot of the major nations are doing that. They're working on that, and they understand it.
But but essentially it's all preliminary, right? I mean, you cannot know any of that is actually going to work until you go and do it. But to go and do it, you need 100 million bucks. So that sounds like a bottleneck too.
Yeah, so I call it 100 million. That price has to come down. How these things are financed, it might be private, public capital. The Japanese iSpace company is interesting because they've really leading the way in um, funding that company, uh, funding missions, and they kind of a very, I think, because it's the Japanese mindset of they're going to do it, like they're not going to get sidetracked. They're very devout to that. Um, but once it's like anything with technology, it starts off expensive, then the price comes down. And when the price comes down, more companies, for example, a large mining company might say, okay, we're going to investigate we can allocate X% of our exploration budget to a lunar resources opportunity, because if we don't, someone else might get it. It might be that kind of situation.
I where the resource market is right now, I find that hard to believe because of the prices of some of these companies, right? That's why we see value in them because they are trading at supposedly lower market cap than what the value of their metals in the ground is. Here on Earth, where we have a very clear, still risky, very risky, but a clear process of potentially getting them out. So having the mining companies get involved up to that level is I don't see that being 10 years away. Do you think that's 10 years away?
If and here's where the big if comes in. With more exploration effort, when more targets are found, that it might be some exotic metal that is just too good to pass up on. That's how I see it. I mean, there's no use, getting iron from the moon and dragging it back to Earth en masse. It's not going to work. Even gold um, is a tough one um, at today's price. But
Okay.
other things that are of interest are platinum group metals and rare earth elements, critical materials, where it's not only the price is going up for whatever reasons, but also the supply chain is well, the supply chain, who manages the supply chain, for example, with China having more control over the supply chain of critical materials, it kind of means Europe has to look somewhere else. If Europe doesn't want to do business with Russia or China, and is getting squeezed out, then the big question is, well, where does an innovative country or group of countries like Europe go for their high value materials, which are integral um, to their economies.
Hmm.
You know, and that's the kind of the play I have is, you know, there is right now today, it's very hard to paint or to build a business model that works completely. But as you go into the future and you say things are going to happen, where do you go? What's already in development? Um, the moon's there. Com the Chinese aren't wasting any time. You know, they're going there. They're already there. So it's already in momentum. It just kind of takes shape as it goes along.
What is this similar or is it way different than asteroid mining? And I'm asking because there's one article that I'm trying to find that I read a couple of days ago.
Is it like about a $1 trillion asteroid or something? Or
Yes, 2.3 trillion pound asteroid. So it's yes,
yeah,
something along those lines.
yeah. I imagine the journalists are having a little chuckle to themselves because they get to write a really nice headline. You know,
If you're
um,
writing about mining asteroids, can you really call yourself a journalist? That's another philosophical question. But yeah, go on.
yeah. So an asteroid of that size and value. I mean, we all know if you can drag it back to Earth, the price of the resource is going to drop through the floor. Um, a lot of these M-type asteroids, high nickel, that's where you're going to get your platinum and your
Hmm.
group metals. They're way out in the Cooper Belt. I don't see it being a reality in my lifetime. They're just too far out. And even the near Earth objects that come close to Earth, how are you going to catch it? Like, the rare asteroid missions that have been done, they're quite small. The sampling they get is quite
Hmm.
small. They do it. This is the amazing thing. They actually do it. But I think that the asteroid mining, it's a bridge too far for me right now. But the good news is the moon has done a good job of capturing asteroids for billions of years, and they're all scattered all over the moon. So that's my theory: is go to the moon and try and find out what's on the surface there, and reap the benefits. But the whole journalistic dream of a $1 trillion asteroid, it's good. It's good for copywriters. Um, but saying that, there is an interesting chart of the price of silver going back 1,000 years, and it back in the 1,000 years ago, the price of silver was equivalent to definitely not what it is now, which is like $30. It was worth way more. Let's call it $500. And then the Spanish and the Europeans got to South America. America started bringing silver over, and you can see the gradual decline of the price of silver.
Hmm.
So that's an example of they went somewhere, they got something that was of high value. So before the new world was opened up as a resource for silver had a higher value in Europe. When they started bringing more silver over, the price started to decrease.
Simon, you have wild stories. I have to look into these things. They're interesting stuff that you're bringing me here. How is it different? Is it different because asteroids are physically further away and because they're not in orbit? Is that what you're saying?
Okay. One, they're physically further away. Um, Two, we're not actually in the business. So the evolution of spacecraft technology is the most expensive infrastructure ever built, I think, is the International Space Station, which is in low Earth orbit. Um, it has a lifetime. I think they're going to keep it alive for another 5 or 10 years. Um, we just don't have the technology to go to an asteroid right now and apply a massive high amount to get out there and apply a massive amount of high energy to start, separating the elements
Hmm.
and getting the elements of value out and then shipping it back. Um, it's just an engineering problem that I don't see being solved anytime soon. Um, so that's why I look at the moon as a realistic objective. Um, There's been, I think, to date about 80 missions to the moon. There's lots of companies building new landers, new technology to look at the moon as a commercial objective. Um, Asteroids, if an asteroid or like an M type meteorite comes within Earth's gravitational pull and maybe it gets trapped, and then that's a different category. Then someone's going to have to build the spacecraft to go out there, capture it, apply a lot of energy to break it apart, manage the process, and then bring it back.
All these things sound almost as expensive as my wife's addiction to shopping. So I'm thinking how you finance these things. And you brushed upon it a little bit, but it is one of the main points that I want to discuss here. How do you like who finances these things? How much money does it cost you to run your company and answer these unanswered questions?
Yeah, this is a really good point because it's something that we have to look into all the time. So, as a company, we make sure that we can survive recessions, never run out of money, and keep your costs down. Because if mining the moon is a 10-year thing, then we're not a startup that throw lots of cash at it and oh, if it doesn't work after 6 months, try again. No, we have to keep alive. Uh, there's a lot of public funding to develop the technology to extract resources from space. So there's the science side of it. The the big investors uh, are not there that from my point of view. Like if a major mining company said, we're gonna put 10 million or 50 million, that would change things. So we're not there yet. Aerospace companies or space companies um, are edging towards that because they rely on a rich heritage of designing spacecraft and equipment. So if you're a satellite maker, it's not that hard to make a satellite for the moon. It's not that hard to go the next step of making a lander because you've already had decades of engineering experience designing spacecraft to design the extreme environments of space, radiation, temperature variation, etc. So you have a space industry that's has the know-how, has been living off supplying satellites for commercial use. The biggest driver of the space economy is commercial satellites. All the internet, TV, broadcast. A lot of these space companies they have had government contracts to fulfill orders for missions to carry out science, like go to Mars or something like that. So, as I see it, the expertise building spacecraft um, is getting us to the moon. It just needs a larger investor to come along and say, yeah, we want to make a concentrated effort to explore for resources, to fully understand what's there and where. That changes everything.
Right, but then it goes back to the point of who finances this. But maybe let's talk about it for you to advance this on schedule for that 10-year framework for you to work in combination with your G&A burn. How much money do you need per year to again advance on schedule and keep the lights on?
Well, we wouldn't do it alone. We'd do it with technology partners,
Okay.
and we'd work out what their budget is to build technology for lunar exploration. Um, but I think back to your point of who finances it all in its entirety, that is an ongoing question. Uh, the good news is that people in general understand that um, if you allocate your own investing portfolio, like you're not going to put all of it on space resources. You might put a tiny bit of it on.
Mm.
And for us, that's the important bit because investors are everything. Um, so we see that there's investors out there who understand it, but also understand that it's risky and it's long term. It's not something that's going to make them double digit returns overnight.
Yeah.
Um, there's other things coming into play at the moment as well. So the in my life, the I've never seen so many choices of investment um, that are kind of removed from quality.
What do you mean?
Well, I know I'm gonna, get heat for this, but what is more rational for the future? Investing in a digital coin, uh, or investing in an operation to extract metals from the surface of the moon? Yeah.
That's a tough question because I am skeptical of both. I can see the utility of Bitcoin. I don't count that as crypto. Um, with coins though, this is we might get philosophical again, but with coins though, I suppose there is a perceived value because you can. It's the greater fool theory, right? That's the main thing that's happening in most of these things out there, not in all of them. With this moon mining, that's basically the point that I had before. Like, who's going to be your greater fool? Like, who is it going to be a major mining company? Is the government going to take you over if you find $1 billion, $10 billion worth of metals on the moon? So that's what it goes back to. But what did you? So how much money does it cost to run a company like you? To go back to that for a second.
Well, the costs, because we're more analytical, um, server costs, mapping costs, um, yeah, that's it. So we keep it low. Now, another company that might want to, make rovers, they can try and keep costs down by 3D printing parts or using off-the-shelf equipment. It just varies. I, as an individual, say, look, we as a business, we have to keep everything glued together and work out what the supply chain is and build a business model to make it possible. Other companies might say, well, we're building as back to the example of a rover. A rover might cost X hundred of thousand if it's mass produced, but it might cost, in the case of iSpace's mission, I think it cost, close to 80 million or 100 million,
So like I'm trying to get an investment case, if you will, and I'm
Okay,
trying to
so
look into.
the
Yeah.
investment case for space resources is fund it with the perspective to work out the business model based on locations that have resources there, and look at it from a mining perspective. How does one secure a location on the surface of the moon that, let's call it a high value location? How does one secure enough of them so your risk is not all in one mine? How do you get landers there? How do you get to verify the resources in the regolith? And then try and work out the value of these resources to a customer back on Earth, or it might be a customer on the moon, for example, a space agency that wants to build a base, and you say, well, we've got an area where there's enough titanium to build X amount of shelters or structures or landing pads.
Yeah.
I think that's probably the most in the next 5 years possible. There's enough engineers out there who want it. This is another strange thing. Well, it's not actually strange. There's enough engineers who want to build the infrastructure. There's no shortage of talent. There's no shortage of designs and concepts and desire. There's just a shortage of absolute capital to make it possible. Another strange example I have is, if the government's changed their tune and said, "Oh, you know what, we're going to do it. Here's 100 million or a billion. Do it." It'd be done. In my life, I see governments, throw money at, let's just say, infrastructure projects which are not very. I don't see them lasting that long, or they well intentioned, and perfectly executed, but I would disagree with the fundamentals of some of them. I don't want to pick fights, but if governments said, well, I'll give you an example. If the US government said, oh, maybe we don't need another aircraft carrier battle group. Maybe we just, take that money and set up a moon base. Could be something like that.
Hmm. Yeah. There's a lot of unanswered questions here. So it's a lot of ways to go. Let's maybe talk a little bit more specific though about how you do it and some of the obvious, te- again, more more technological questions, if you will. Like, let's just assume it all works out. There's the governments go in, you find investors, you have money, you want to do it. Um, lunar dust, the first thing that pops to mind. I don't know if it's real or not, but I think I read about it. But it's supposed to be abrasive, right? It's
Yeah.
electrostatically charged. It basically does not want to get messed with. And again, this is mostly theory, but it's very hard to impossible to handle. How do you handle that?
I'm not an expert on lunar dust, but from the research I've seen is it's the killer. So there's whole strains of technology which is focused on lunar dust mitigation, how you get away with it or avoid it. This is just another one of the engineering challenges to do with anything in space technology. So number one is radiation. Sorry,
Hmm.
number one is you're in a vacuum. Number two is radiation, temperature variations, etc.
Yes.
So satellite makers have been dealing with these things for years. Operating the moon, you have all that plus lunar dust. Uh, so the from a basic engineering point of view, it's not an impossible thing. It's just I think another one of the hazards of the moon, but it's it, it's obviously a problem, but it's not the end.
Hmm. So I mean, there's other stuff again, energy transportation. Water is a big thing on Earth that we're struggling with in some places in Latin America, for example. We already have these deposits, like we've proven they have value. People might want them if the water thing was solved, and it, it sounds like a small issue, but it's a huge issue. It's literally the difference between zero and value for some of these assets. How do you solve that?
Yeah, water. Going to eat my own words here on asteroids, but one source of water in space is dirty snowball asteroids. They're flying around, but just hard to catch. Water on the moon, it's hasn't actually, as far as I can tell, been absolutely proven. But the theory is in polar shadowed regions of the moon, for example, the South Pole, probably see it down here. Um, there's craters that haven't seen sunlight in a billion years. So the theory is that there's trapped hydrogen particles, and that can be extracted, and you can get hydrogen, oxygen. You can extract and water and oxygen out of it. Um, there's technology underway being developed to do that. I'm not sure if any of it is scheduled to go as payloads to exploration missions to the moon at the moment, but I know it is one of the priorities of NASA and European Space Agency is to solve this problem of how can you extract water from the polar shadowed regions of the moon. Because once you unlock that, then it starts to solve a lot of problems. It means if you have a manned base, if you want to go down that way, there's a crew can live easier. It doesn't have to rely on shipments from Earth. Uh, but in terms of mass water, I don't see it on the moon. I think it might be available with enough technology and a lot of energy to separate it from the regolith.
Hmm.
Um, yeah, I hope that answer your question. Water is a tough one because you can't go without.
Correct. I mean, again, other stuff, just energy transportation. What is it? How would that look like? Are they going to be, I don't know, solar panels on the moon, or like how would that work?
Yeah, so energy, I think that uh, just bite the bullet and rely on nuclear. Um, Simple. There's concepts called a space-based solar power, which is let's just call it football fields, solar panels that can direct the energy to a certain location. So that's already been looked at here on as a solution, like a net zero solution for Earth is to have a space-based solar power production of energy being back to Earth. As you can imagine, there's a few issues with that. See, that could also be done for in a cislunar environment or on the moon. For me, as a pragmatic person who wants to find out how we can have a proper lunar exploration campaign underway with a fleet of landers, the energy thing comes back to, well, make sure that the landers have their own energy on board, which will probably be, some kind of nuclear option.
Mm. That sounds like an expensive solution too.
Yeah, look, it's all expensive, but how many small modular nuclear reactors are out there? How many submarines run on nuclear power? Like it's it, it's perfectly doable. I think the big challenge is convincing the voters, to convince the politicians that the direction to explore the moon for resources is something that has massive benefits. Um, and a lot of the benefits are that by investing in space programs, you start to build out other industries. Individuals have more of a reason to be employed or study something because they're doing something new. And this is something I think should be more prevalent in today's conversations. Is that for the younger generation, where are you going to go? Like Earth's been explored. All right, maybe you can do some deep sea exploration. Great. Earth's been mapped. There's so many satellites at the moment mapping measuring everything on Earth from geology, atmosphere, blah blah blah. Where does humanity go right now? What's the next objective that is breathtaking, new, dangerous, expensive, and risky? It's the
Oh,
moon.
I think it's just normal mining. I mean, mining is all these things, isn't it? Just earth mining.
Yeah, Earth mining is, and I don't think there'll always be Earth mining. Uh, with space resources, it's extending that to our next planet.
Hmm.
Yeah.
What are you said? There's many benefits. What are under benefits? Like I kind of just approached this again, just from the beginning of the conversation with my capitalist brain, thinking like, I mean, there's benefits if I can make money. There's benefits to my wallet. What are other benefits? Something that's maybe not measurable, or something else. I mean, something along the lines of what you just told me.
Yeah, I'll start with the how I see the most simple capitalist perspective is go to the moon, find locations of resource or find locations of high value resources that could be used in an in situ resources utilization for the production of a moon base. Simple as. If you're the contractor who's got the gig to extract regolith, convert it into sheets of titanium, as an example, that's one business. Your customer is going to be a space agency. Fair enough. Uh, Next thing is, if there's a resources area on the moon that is something so exotic and the value is there, let's just call it a platinum group metals deposit because it's just easy to understand. The world, our digital economies, full of more devices, need more exotic metals and minerals. If you can find these on the moon and extract them out of the regolith, or there's some kind of mother lode somewhere that's maybe 300 meters below the surface and make an open pit mine, then that is a business that 10, 20 years in the future can turn a profit, because in 10, 20 years, the cost to launch is coming down and the cost to come back from the moon is coming down as well. More
Hmm.
companies are building the cislunar supply chain. Uh, a big one that we're watching is SpaceX's Starship, which is just a behemoth in terms of launch capacity. If that's up and running as planned, with a regular service, then you can start to model, well, what is the cost to get to the moon and come back? What is the cost to put to position infrastructure or mining assets on the moon? And what is the cost to bring um, resources back. Then it all then all the pieces start coming together, and you suddenly see, oh, okay, there is a path here. Right now, there is uh, the path is not clear because we're kind of encumbered by politics and costs and things like that. But as technology improves, becomes cheaper, it becomes a lot clearer.
Mm. What does it depend most on? You said technology and politics and financing, the topics that we're talking about here today. What does it depend the most on? Like, what do you think is the biggest bottleneck? Is it technological development, finances, politics?
I think it's politics. I think that the the current I don't want to get into trouble, but I think the current wave of self-absorbance and this kind of, I don't know, paganistic sense that the world's ending, um, it just ends in defeat. And it ends in massive infrastructure investments, which I think are just like bad decisions. Um, I'm not in the business of being a politician.
Mm.
Um, but if humanity is going to spend, let's just say, 100 billion doing this when it could do that, but we do this because if we don't do it, the world's going to end, or um, humanity's going to do that, and it's only going to work out its mistake afterwards. And in some cases, it doesn't even accept it's made a mistake. So I have a feeling that if the politics, the people said, you know what, we want space exploration, we want to do it, bang. We don't want to do this or that or whatever. We no, we want it all, but we also want space exploration. It really comes down to that. You know, I see it already in terms of how the investing community of ESG, and I'm like, what could be more ESG than like going to the moon and getting resources from the moon and getting energy from space? Like, what do you want?
But that sounds more like a funding issue because you're saying you think the problem is that politicians are not putting enough money toward space exploration. So it's not necessarily a political issue, like they're not stopping you in terms of permits. It's really, this sounds more like a capital issue.
Yeah, so you got a good point. It's not permits. That's as far as I can tell, not the problem. The problem is selling exploration to a public that over the last decades has just been thrashed over the head repeatedly with concepts which are not really, I think, sound or technologically progressive or positive. I'll give an easy example is I was talking to a friend of a friend, this kid, he's like 10 years old. And, what do you want to do when you grow up? First question an adult like me asks a kid, I know therapists would, belittle me for asking children this question. What do you want to do? And this kid's answer was something like, he's got a fear of, what's happening with the environment, and I'm like, what? Like, to me, he should be using, to me, the idea would be when he's 30, which is in 20 years, he's operating a robot on the moon in a trench, looking for critical elements. That's the future I see. The future is not him being 30 years old and in his basement scared that the sky is going to fall because that's the fashion at the moment. Now I'm not denying things that I understand that there is pollution and all that, and fine. Let's build more cleaner infrastructure. Let's tackle these issues. But I think it's become this very persuading influence that stops people thinking in a positive way about, well, what should we be doing? Well, what do our youth of tomorrow want to be doing? You want a job mining on the moon, or you want to be, I don't know, repairing wind turbines?
Yeah, that kid should go to a mining site. I think I'll take my kids to mining sites.
Yeah.
Um,
Well,
but
this is a really good point. So I was a child of the 80s and the 90s. There was no internet. Fun was, taking something apart, building it. I think for the younger generation, everything's on the phone. You try taking a phone apart and putting it back together and getting it to function again. I did it a few months ago with a laptop, and drove me crazy. In the old days, you could do it with a PC. You could see how things work. So I think the younger generation is losing this feeling of the physical
hmm,
and getting stuck in the virtual.
maybe the physical future for them is on the moon. Yeah, Simon, this has
Yeah.
been a good overview. I appreciate it. I think again, there's a lot of questions. There's a lot of ifs and buts. It's an uncertain point. It's an uncertain point in this industry's future, but it warrants conversation. And I appreciate you reaching out. I appreciate you trying to educate me on this. Let's stay in touch and see what kind of developments you have going over the future. But yeah, anything else that I'm forgetting to ask you? Well, what should we be talking here?
Lobby your politician. No, I think that the behind me, I get to meet a lot of the young and old entrepreneurs, space resources community. They're out there. They want it. Simple as. It's not a a permit issue. It's a funding issue. Um, Funding from public side, governments, space agencies space agencies need to be given a mandate from the politicians to explore something like space resources or more space exploration or whatever. The investor community needs to understand that. I'm going to use the digital assets as an example. A digital asset is a digital asset. It can fade away tomorrow. Space resources is about physical assets. It is about extracting raw resources from one location, moving to another location and retooling it or making it for a different purpose. So that's how I see it. If we were talking about this as a mining object, and we refused to mention it was on the moon, it would sound plausible, a bit exotic, but it might be up there with, or sorry, down there with deep sea mining.
Yeah. Yeah, it is. Deep sea mining is another question. Well, another something that seems to be closer for now because it's physically closer, but also because maybe because yeah, governments want to spend money on it. I mean, look at what's happening in Asia now. I talked about it last week, I believe. So that's interesting too. But yeah, Simon, thank you so much for stopping by. What do you want to leave me with any links, anything that you want to, what is it, lunar resources?
Yeah, Lunar Resources Registry. I can put a link in. We have online maps of the moon showing all missions to the moon.
Hmm.
We have another map for governance where we try and all work out where development zones are for potential lunar mines. And we also have our main company, Space Ventures Investors, where we've invested in pre-seed space companies. It was by our investing in Earth observation startups that I got to understand how to build a moon observation company. You follow? So
Yeah,
this kind of software you'd use, but we use it for the moon.
sure.
It's nothing happens by chance. Everything happens in incremental steps.
Hmm. Good. Well, thank you so much. I'll leave those links in the description below. But I do appreciate you investing your time in me, and thank you so much for sitting down with me.
Yeah, and thanks for having me on your show, and thanks for the work that you do to bring these concepts out to a wider audience.